All right, these are notes for section 2.8 pre-calc. We are solving inequalities today. The last few days we've been focusing on how to solve equations, and we had a technique of multiplying everything through by whatever that LCD would be in order to get rid of the fractions. Okay? That technique doesn't work on inequalities, so we have some different things we're going to try. Main focus today is going to be on how do we make a sign chart. We're going to use that both with algebraic and graphical techniques to look at the overall picture and be able to tell where is your inequality less than 0, where is it greater than or equal to 0, that type of thing. Okay, next week we'll focus on the real world inequalities. So I had asked you just to try the first and the third one of these. Notice these are not equations or inequalities, they're just expressions. So we don't have another side where we can multiply things to both sides and keep it balanced. So in order to simplify this and combine it into one fraction, we have to get common denominators. Okay? So what would we use as our common denominator for the first one? All right. So to get a common denominator, our first piece, this x squared, has to be done. What do we have to do to it? Multiply it by x over x. If you're going to change something to get a common denominator, whatever you do to the bottom, you have to do to the top. Yes? So we have to multiply this by x over x. And what that gives us is an x cubed over x. And now we can add a 5 over x to it because now we have a common denominator. So our simplified expression, combining it into one fraction, would be x cubed plus 5 over an x. Okay? For part C, what would our common denominator be? Both two bottom pieces. Okay, so we need to have 2x plus 1 and an x minus 3 in the bottom. What's missing from the first fraction? So we have to take the first x and multiply it by an x minus 3 so that it has this denominator. Yes? And then what do we have to do to the second one? Okay, so we're subtracting 2 and we have to multiply it by 2x plus 1. Yes? And now we can simplify everything on top and get it all cleaned up. We've got an x squared minus 3x. Then we're subtracting what? Minus a 2. Remember, you're subtracting everything? So watch how you distribute that sign. All right, and then simplifying the top gives us x squared. Yes, minus 7x minus 2 over our common denominator. Okay, so that's just a quick little algebra review for some of the things we're going to encounter today as we go through our examples. Okay? All right, so we are looking at polynomial inequalities. We'll also get to some rational inequalities towards the end of our notes today. For a polynomial inequality, our choices are the function can be greater than 0, it can be greater than or equal to 0, less than 0, less than or equal to 0, can be not equal to 0. Those are all considered inequalities. Okay? It says there's a fundamental connection between the inequalities and the positive or negative sign of the corresponding expression. So if we are trying to solve for f of x being greater than 0, we're looking for x values that make our function positive. And if we are looking for solving f of x is less than 0, we need values of x that make our function negative. Okay? To do that, we are going to use something called a sign chart. The first step, we need to find the critical points, which would be where our function is either exactly 0 or it's undefined. All right, undefined would be, for example, vertical asymptotes. Okay? And then what we're going to do is we're going to make a number line and we're going to place those critical values on it. And we're not really concerned about the spacing on our number line as much as getting them in the right order smallest to largest. Okay. Our next step is to pick a value in between those critical points and on either end of them. So in other words, our critical points are taking our number line and splitting it into little interval chunks. We need to pick a number in each of those intervals. And what we're going to do is we're going to plug it back in, and we're going to look at each of the factors. Does it end up being positive or negative? And then on our sign chart, we're going to indicate, did we get a positive or negative answer? And we'll use that to solve our inequality. Okay, we're going to skip example 0 because it's a lot like one of the other ones we do. So example 1, it says finding where a polynomial is 0, positive, or negative. Notice our polynomial is already in factored form. Determine the real number values of x that cause it to be 0. We'll start with that. What are the zeros of that polynomial? Negative 3. Yeah, that next factor is going to give you an imaginary piece, right? Which we wouldn't see on a number line. Right? X squared plus 1 won't ever be 0. But we also have, careful, x minus 4. What's the 0? It's a 4. It does have a multiplicity of 2. So in terms of a graph, what does that mean? It bounces there? Okay, so keep that in mind. All right, so we're going to make a number line. And we just have 2 critical values for this one. There's no denominator, so we don't have any vertical asymptotes to worry about. All right, we're just strictly looking at zeros. I want you to put negative 3 and 4 on your number line. And above it, I want you to write 0. At those 2 spots, we are exactly equal to 0. Okay? Now, to make our sign chart, we're going to pick a number in each of those intervals. In other words, I need something that's smaller than negative 3. Something over here. Negative 4. That works, right? Anything smaller than a negative 3 will work. Okay? What we're going to do is we're going to take that number and we're going to put it into each of our factors. And we don't care about the exact number that we get in each factor. We only care about the sign. Okay? So if I chose negative 4 and I put it into this first factor, negative 4 plus 3 is a negative number. Yes? Okay, so I'm going to write down a negative. In my next factor, if I put negative 4 in there and square it, and then add 1, I get a positive answer. Okay? Plus sign. If I put negative 4 into my second one, or my third factor, sorry, negative 4 minus 4 is negative, but it's getting squared. Okay? So when I look at what would the resulting answer be in terms of its sign, a negative squared ends up being positive times a positive times a negative. So the overall answer is going to come out negative. Yes? That's all we care about. I don't need to know what negative number it is. All right? So on this sign chart now, I'm going to write negative for that interval. So that tells me that any value for x that's smaller than a negative 3 is going to give me a negative y value. Okay? Now I need something between negative 3 and 4. 0 is a perfect one. It's really easy to plug 0 into factors. All right? So let's say we try 0 here. If we put 0 in the first one, do we get positive or negative out? Positive. Putting a 0 in our second factor, positive. Putting a 0 in our third factor, a negative squared. All right? So overall, my answer would be positive. Okay? Now I need a number bigger than 4. All right, let's try 5. Okay, putting a 5 in the first factor gives me positive. Putting a 5 in the second factor will give me positive. Putting a 5 in the third factor gives me positive squared, which is positive. So overall, I am in a positive section. Okay? Now, I want you to think a little bit. We talked about this 4 having a multiplicity of 2 and the idea of that the graph would bounce there. So does it make sense that if I'm between -3 and 4, I'm positive? I'm going to bounce at 4 and still be positive? So that fits? Yes? The -3 had a multiplicity of 1, which means my graph should cross the x-axis there. So it makes sense that I'm negative here and I'm positive over here. Yes? All right. So let's look at a picture. That's what the graph would look like. Does it match what our sign chart's telling us? Yes? Okay. So to answer our question, it said, where is the function 0? Okay, so for part A, we are 0 at what? And just 2 exact values, right? Not an interval, just 2 points. So we're going to put that in set notation, -3 and 4. For part B, where is my function positive, meaning strictly above the x-axis? So everything from here, -3, is it forever? What happens at 4? I hit 0 at 4, right? I don't want 0, I just want to be positive. So I have to take 0 out of that. So I have the interval from -3 to 4. And then I'm going to jump over the 4 and then go to infinity. Okay? All right. Where is my function negative? So just the very left interval? Yes? Okay. So that's how we use a sign chart. Now, in the first one, it was factored for us, which was nice because we could identify our zeros very quickly, and we could use our little sign technique of, plugging numbers in and deciding is that factor positive or negative. In this one, we're not given it in factored form. It's not one where a grouping technique will work. So let's look at that technique we had a while ago where we list our possible zeros, the possible rational ones. We need factors of 24 over factors of 2. So plus or minus 1, 2, 3, 4, 6, 8, 12, 24, all over 1 and 2. Yes? Okay, so take a minute and graph it on your calculator and see if you can identify where those zeros are. Yell them out when you see one. Anybody else agreeing with that, a -2? Yep. Okay. Three halves? Does that look appropriate? I'm going to put that one down as my third one so that I only have to do the fraction in the smallest round. Positive 4? Okay. So take a second and go through that synthetic process and check that all 3 of those work. Try to do this on your own. Double check up here if you need to. So did they all work? All right. So can we write the factors now? Because that was the whole point in getting those zeros. I shouldn't say the whole point. We need them for our sign chart as well. But if we have the zeros, can we write the factors? So a -2 here would give us a factor of x plus 2. A 4 gives us a factor of x minus 4. And the 3/2 gives us x minus 3/2. But remember this 2 here is one of our constants, right? One of our factors, that's just a constant. And we could put that 2 back in if we wanted to. Yes? We can continue the process with the 2 in or out. It doesn't matter. All right? So let's make our sign chart. We said our zeros were -2. 3/2 would be next. And 4 is the farthest on the right. All right. At each of these, we have a 0. How many intervals have we just divided our line into? So we need to test 4 different numbers, yes? All right. So if we put something smaller than a -2, say a -3, if we put -3 in for x, is our first factor positive or negative? Okay. Second factor is negative. Third factor is negative. So 3 negatives all multiplied together is negative. Okay. Testing something between -2 and 1.5. 0 is a good one. All right. First factor becomes positive. Second one is negative. Third one is negative. So overall we are positive. Okay. Something between 3/2 and 4. 2 would work. All right. Plug a 2 in. First factor is positive. Second factor is negative. Third factor, 2 minus 3/2 is positive. So overall, a positive times a negative times a positive is negative. And then something bigger than 4. All right, we'll test 5. Putting a 5 in, first one is positive, positive, positive. So multiplying 3 positives gives us a positive answer. Yes? Now, I want you to think about the original polynomial that we were given. Our first term was a 2x cubed, yes? So what shape would that look like? A cube has a twist to it. Is it low on the left, high on the right, or the other way around? It goes from low to high? So on the farthest to the left, as we go towards negative infinity, our arrow should point down. Okay, looking at our sign chart, in this farthest section here, are we pointing down? Right, we're in the negative range. Okay, then we go to positive, so we cross through 0 here. We cross through 0 again here to become negative. Then we cross through 0 here again to become positive. And on the far right, our arrow will point up, and on the far left, our arrow is pointing down. Okay, so our sign chart is fitting with all the stuff we know about the shapes of the graphs and the end behavior of them. Okay, so the question was, where on my polynomial am I strictly greater to 0? Greater than 0. So I have to be completely above the x-axis. Yes? So what intervals do I have that? So I'm looking for the positive sections, right? So in between -2 and 3/2, do I want to include those values? No. Because at those 2 points, I'm exactly 0, and it doesn't want me to be 0. It wants me to be greater than 0. Then I also can use what other interval? Good, 4 to infinity. Okay? Oh, I forgot to show you the graph. Does it fit what we were predicting? That shape? Okay. All right, this one. It says to solve this one graphically. And right now we don't have one side equal to 0. Could we get that? All right, let's rearrange our polynomial inequality. We've got x cubed minus 6x squared plus 8x minus 2, and we want to be less than or equal to 0. Okay? So go ahead and graph it. There are going to be 3 zeros, and we're going to divide up the work here. So the table's over here on my right. You guys find the leftmost 0. Middle section of tables, you guys find the middle 0. And over here, you guys find the farthest to the right. All right, what are the zeros based on what our calculator showed us? 0.325, middle one, and the farthest to the right. Okay, we agree? All right, so what is happening in my graph? We had these 3 zeros. All right, and the question that we're asked is, where are we less than or equal to 0? So for my graph, that means I could be in this part here, or I could be in this section here. Yes? I just don't want to be above the x-axis. Okay? I want to be less than or equal to 0. So on or below the x-axis. So what is the interval for this farthest to the left chunk? From negative infinity to 0.325. Can I be at 0.325? Yes, because this time it said we could equal 0. So squared off bracket. And then I have to jump to what? 1.46 and go up to 4.214. Does that make sense? Okay. So the next one, we've given you the graph. What do you notice about it? It kind of looks like a parabola. It's not actually a parabola. If you look at the equation, it would be a quartic, right? It would have an x to the 4th in there. But end behavior, arrows are still pointing up. Do we ever hit the x-axis? No. So the question here, where is my polynomial greater than 0? The whole thing, right? The whole graph is above 0. So I would say negative infinity to infinity. Where is my polynomial greater than or equal to 0? Same thing. Where is my polynomial less than 0? Nowhere. So we say there's no solution to that. Where is it less than or equal to 0? Nowhere. All right. Now, what if it touched the graph and then bounced back? Then I do have places where I'm equal to 0, right? I'd have to identify that. So take a look at the next example. Look at your graph. At all points in that graph, we are either at 0 or in a positive section. Yes? We don't actually dip below into the negative range. So the first one says, where is my polynomial greater than 0? Well, first of all, we have to identify what this point is. So let's look at our equation. This first part is going to give you imaginary answers. Okay? It's not creating any real zeros. But what's the 0 from this second part? Okay, so negative 5 halves would be that point. So where am I above 0? I have to take out what number? I have to take out negative 5 halves because there I'm at 0, right? So I am going from negative infinity to negative 5 halves and jumping over that. Now, how does it change if I say I want to be greater than or equal to 0? Now it can be everything. I can include that 5 halves. So negative infinity to infinity. Where am I less than 0? I'm not. Okay? No solution. Where am I less than or equal to 0? At negative 5 halves. And if it's a single number, remember we don't use the interval notation, we use that set bracket. They call that roster notation. Okay? All right, example 5. We have 2 left, guys. You can do this. I know, Allie. I'm worried for you. I'm about to call the paramedics.
Yeah, me too. 911 on speed dial.
911 on speed dial. Actually, you have to dial 911 because you have to dial 9 to get out of the building.
True.
Yeah.
Dang school.
Yeah.
Being extra.
Okay. Example 5. Notice that we have a rational expression here. There's a division sign there. So I'm going to rewrite it where we can see it a little easier. Okay, so we have this rational expression. And because we have a denominator, we have some other critical values that we have to worry about. It's not just the zeros anymore, but we also have vertical asymptotes. So where do we find the vertical asymptotes? Zeros of the denominator. So we are undefined. I'll go back to part A in a sec. We are undefined where the denominator equals 0. So in this example, that would be at okay, so those are vertical asymptotes. All right. Where are we equal to 0? Remember, zeros are the same thing as x-intercepts, right? So where did we look for those? On the top. So what makes the numerator equal to 0? Okay. So when we go to make our number line for this, for our sign chart, we're going to have different types of critical values. Some are zeros, some are where we're undefined. Okay? So we have a vertical asymptote at negative 3. So above it, I'm going to say undefined. At negative 1/2, we are 0. And at positive 1, we are undefined again. Okay? All right, so we are going to test our points again in our factors, but notice that we have a numerator and we have a denominator. Okay? So what do we get if we put something, what should we pick? Something smaller than negative 3. She said negative 5 first. We'll do negative 5 on this one. Negative 5 is more fun than negative 4. Okay, put a negative 5 in here. What happens on the top? What's our numerator become? A negative. Remember, we're just worrying about the sign? Okay, so top would be negative. And then on the bottom, if we put a negative 5 in, we have a negative for the first one and a negative for the second one. So what's a negative divided by a negative times a negative? It is?
The negative turn positive, so this one is K.
Okay, we're getting negative, yes? Several of you are coming up with different ways of saying that, but we do get negatives. Okay, something between negative 3 and negative 1/2. We could use negative 1, all right? What happens on the top if I put a -1 in there? It's negative. On the bottom, if I put a -1 in the first factor, it's positive, and in the second factor, it's negative. So my overall answer is going to be positive. Okay? I need a number bigger than -1/2. 0 would work? Okay, what do I get on top? A positive. On the bottom? A positive and negative. So overall, negative. And then something bigger than 1. Carter wants to use 7. We'll use 7. All right. Top becomes positive. Bottom is positive and positive. So overall, it is positive. Okay. So based on our sign chart, we can answer part C here. Where is my function greater than 0? So strictly positive. Between -3 and -1/2. And then from 1 to infinity. Remember, we cannot equal those endpoints, right? And where is my function strictly negative? The other ones. -infinity to -3 and -1/2 to 1. Yes? Okay. Check our picture. Isn't that lovely?
It's so lovely.
Think about where our vertical asymptotes were. We had one at -3 and one at +1. So that fits. We said we had a 0 at -1/2. And we said past -3 on the left, we are negative, which fits our branch here. Okay. We said between -3 and -1/2, we were positive, which would be this chunk. Between -1/2 and 1, we're negative again. And then between 1 to infinity, we're positive again. Okay? So have you noticed that we're doing a lot of things algebraically, but we're also looking at a graph to kind of back it up and make sure it's matching what we think should happen? All right. Our last one. For real?
I wish I could have.
It's the last one for today. It's not the last one forever.
Except when you don't have homework. On Friday.
All right. Now, we have an inequality instead of an equality. When we solved this type where we had fractions, when we solved it before, we said, let's just multiply everything by an LCD and get rid of all our fractions. We can't do that with inequalities because if you multiply an inequality by a negative, what happens to the inequality sign? It has to flip. And if we're multiplying by an expression that has an x in it, for some x values, that expression could be negative, in which case we'd have to worry about flipping the inequality all the time. So we need a different technique. So what we're going to do is we're actually going to get the two fractions on the left combined into a single one. This is why we reviewed that thing at the very beginning of class today, getting a common denominator. So what would our common denominator need to be?
2 on the bottom, multiplied together.
Okay. So what fraction or what factor is the first fraction missing?
X minus 1.
So we're going to take 5 times x minus 1. Okay. The second fraction is missing the other one, the x plus 3. Okay. We're just going to clean up that top piece so that we can get it to be more of an expression like we just did in the previous one. Okay. So cleaning it up, we have 5x minus 5 plus 3x plus 9. Which gives us what? Now, we could go and solve that just the way it is now, right? We could make a sign chart. Yes? Could we factor the top?
Yeah.
What could we take out?
4.
We could take a 4 out. And then could we divide both sides by 4 and get rid of that? Would that flip our inequality at all if we divide by a 4? No. So it becomes 2x plus 1 over x plus 3 times x minus 1 is less than 0. Now, compare that to example 5. It's the same thing we just did, right? So you might be given the expression like we were given in example 5, where they actually show you, right, it's all one fraction. Or they might give you the equation in 2 pieces, and you have to get a common denominator and stuff. So our answer to this is actually the answer we found here. Yes? Where we're less than 0? Okay. All right, so for today's homework, it says 3 through 24, multiples of 3, and then 25 and 26. What do multiples of 3 mean? 3, 6, 9, 12. Yes? I am making you do math to do math. However, I'm giving you fewer questions than if I said evens or odds. So we maybe shouldn't complain too much.